Welcome to three-dimensional coordinates or 3D coordinates, Triparimana Nirupakal. In 3 dimensions, the coordinate axis of a rectangular Cartesian coordinate system are 3 mutually perpendicular lines. These lines are called the X, Y, and Z axis. ఈ త్రిపరిమాణ నిరూపకాలలో పరస్పరం లంబంగా ఉండే 3 రేఖలు, ఈ రేఖలను XYZ అక్షాలు అంటాం. You can see in this figure, this X axis, this is Y axis, and this is Z axis. So in this figure, this line X dash, if you extend this line, this is X axis, and Y dash, Z dash. So these lines are mutually perpendicular to each other. ఇవి పరస్పరము ఒకదానికి ఒకటి లంబంగా ఉంటాయి. మనం 2-dimensional geometry, normal geometry, it is 2-dimensional geometry where we consider only X and Y axis. So here, if you take 3 axes where the 3 lines are mutually perpendicular to each other, and we know in general X axis and Y axis are perpendicular to each other. Here we are taking another dimension Z. All these axes are perpendicular to each other. If you take in the space, you can take infinite number of axes also, but now we are taking 3 axes, 3 dimensions, X dimension, Y dimension, and Z dimension. So this is 3 dimensions coordinates X. So these lines are called X axis, Y axis, and Z axis. And coordinate planes. The 3 planes determined by the pair of axes are the coordinate planes. You can imagine a room. Each wall is a plane. A line, a point, and a line and a plane should be able to visualize the difference between these words. Know what is a point, what is a line, and what is a plane. When you say it is a plane, you imagine it is like a wall, a sheet. So here we get 3 planes. In 2 dimension only we get 1 plane, XY. But if you take 3 dimension, we get 3 planes. One is XY, YZ, and ZX. XY, YX both are same. So in normal 2 dimension, we get only 1 plane. But if you take 3 dimensions, you will get 3 planes. You can see these sheets in this diagram. One is blue sheet, one is green, and another is orange. So just like these sheets, if you insert 3 sheets like this, mutual perpendicular to each other, you can imagine the walls in a room. So these sheets are perpendicular to each other. XY sheet is perpendicular to YZ, and YZ is perpendicular to ZX, and ZX is perpendicular to XY. So they are mutually perpendicular to each other. So plane, you can imagine it is like a sheet. So we get 3 planes, that is xy plane, yz plane, and zx plane. Coordinates of a point in a space in 3-dimensional coordinate system. We know in 2-dimensional coordinate system, a point is represented by an ordered pair x comma y, where x is x coordinate and y is y coordinate. But in 3-dimensional coordinate system, a point is represented by a triplet x, y, z, where x is x coordinate, y is y coordinate, z is z coordinate. So with a triplet, we represent a point in 3-dimensional system. ఈ త్రిపరిమాణ అనిరూపక వ్యవస్థలో బిందువును త్రికంతో సూచిస్తాం. మనం నార్మల్గా 2-డైమెన్షన్ జియోమెట్రీలో ఒక బిందువును ఎక్స్ వై క్రమయుగ్మం ద్వారా సూచించినట్టే ఈ త్రిపరిమాణ నిరూపక వ్యవస్థలో ప్రతి బిందువును ఎక్స్ వై జెడ్ అనే త్రికం ద్వారా సూచిస్తాం. We represent each point in this 3-dimensional coordinate system by a triplet x, y, z. You can remember these points. X-axis, a point on x-axis, yz coordinates will be 0. Just you can recollect the same thing in 2-dimension geometry. A point on x-axis, y coordinate is 0. Like that, in 3-dimension geometry also, any point on x-axis, only x value, x coordinate will be there and y, z coordinates are 0. Similarly, in a point on y-axis, only y coordinate will be there, the remaining x and z will be 0. Similarly, on z-axis, only z coordinate and x coordinate, y coordinate will be 0. And a point on xy plane, point on axis and a point on plane. If any point on xy plane, y, x, y, 0. So z coordinate will be 0. Here z is not there. You can remember easily. xy, only xy, y, z value 0. A point on yz, only yz and x value is 0. A point, any point on zx plane, only z and x values will be there and y coordinate is 0. So in this way, we represent a point on xyz axis and xy, yz, zx plane. Now let us look at some important formulae. The distance between 2 points in 3-dimensional coordinate system, where first point is P, x1, y1, z1, and second point Q, x2, y2, z2. If these are the 2 points in 3-dimensional system, the distance between these 2 points, PQ, or you can take AB, the distance between these 2 points is x2 minus x under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So how do you remember this formula? This is similar to, you can recollect the formulae in 2-dimensional coordinate system. Almost all formulae will be same, only with an extension of z coordinate. మీకు మామూలు ద్విపరిమాణ నిరూపక వ్యవస్థలోని సూత్రాలన్నీ అదే మాదిరిగా వస్తాయి. z నిరూపకం ఎక్కువ ఉంటుంది కాబట్టి థర్డ్ టర్మ్ విల్ రిపీట్. z కోఆర్డినేట్, z పదం అనేది ఇక్కడ ఎక్కువ అదనంగా వస్తుంది. సో ఇన్ 2-dimension coordinate system, the distance between 2 points we know under root x2 minus x1 whole square plus y2 minus y1 whole square. Up to this we know. So in 3 dimension, in addition to this, we get a z2 minus z1 whole square. So if you remember 2 dimension formula, it is only extension. It is easy to remember. You need not worry about this formula. So similarly, the distance between the origin and any point xyz. So ఈ మూల బిందు నుంచి ఏదైనా బిందువుకు దూరం OP is equal to under root x square plus y square plus z square. It is also similar to 2-dimension geometry. So in 2 dimension, under root x square plus y square. In 3 dimension, under root x square plus y square plus z square. So distance between a point to from origin to any point. Similarly, the distance between 2 points and distance between origin to any point. Now, coordinates of a point are which divides the line segment joining 2 points x1, y1, z1, x2, y2, z2 internally or externally in the ratio m is to n are given by mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. It is internal. If you take mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n, is external. ఇది అంతరంగా విభజించే బిందువు నిరూపకాలు, ఇవి బాహ్యంగా విభజించే బిందువు నిరూపకాలు. Even this formula is also very much similar to 2 dimension. In 2 dimension, only we get to 2 coordinates x and y. So it is an extension of a 3rd dimension. ఇది సూత్రం, ఇది కూడా అదే విధంగా ఉంటుంది. Now, this is the midpoint formula. మధ్య బిందువు సూత్రం. We know x1 plus x2 by 2, y1 plus y2 by 2 in 2 dimension. Here, in addition to that, z1 plus z2 by 2. And this coordinates of the centroid of a triangle whose vertices are x1, y1, z1, x2, y2, z2 and x3 by 3, z3. x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3 up to this in 2 dimension. Here another z1 plus z2 plus z3 by 3. ఒక త్రిభుజంలోని కేంద్రాభాసం ఆర్ గురుత్వ కేంద్రం యొక్క నిరూపకాలు 2 dimension జామెట్రీ మాదిరిగానే ఇందులో కూడా అన్ని సూత్రాలు 2 dimension లో ఉన్న సూత్రాలన్నీ ఇక్కడ వస్తాయి, అదే విధంగా వస్తాయి. ఒక z నిరూపకం అదనంగా వస్తుంది. సో లుక్ ఎట్ దిస్ టెట్రాహెడ్రన్, చతుర్ముఖి. ఈ చతుర్ముఖి గురుత్వ కేంద్రం, త్రిభుజానికి గురుత్వ కేంద్రము, త్రిభుజానికి 3 శీర్షాలు ఉంటాయి కాబట్టి 3 బిందువులు తీసుకున్నాం. ఇక్కడ చతుర్ముఖి 4 శీర్షాలు ఉంటాయి. అది ABCD అని 4 శీర్షాలను తీసుకుంటాం. అంటే 4 బిందువులు x1, y1, z1, x2, y2, z2, x3, y3, z3 and x4, y4, z4 ABCD are the vertices of a tetrahedron. Then the centroid of a tetrahedron, if 4 vertices are given ABCD, then the formula is x1 plus x2 plus x3 plus x4 by 4. It is also similar to the centroid, where in a triangle we get centroid. There we have 3 vertices ABC. So x1 plus x2 plus x3 by 3. Here in the case of tetrahedron, we have 4 vertices ABCD, 4 points. So add sum of the x coordinates by 4, sum of y coordinates by 4, sum of z coordinates by 4 in all the 4 points. So this is also similar to triangle centroid. There we take x1, x2, x3. Here we take 4 points are there. That's why 4 x coordinates x1 plus x2 plus x3 plus x4 by 4. Similarly y and z. So these are the some important formulae. This is very small chapter. You get only very short answer type questions from this, but for the knowledge, sake of your knowledge, it is also important. Now let us solve some problems from exercise 5A. First problem, find the distance of P3 minus 2, 4 from the origin. మూల బిందువు నుండి 3 minus 2, 4 బిందువుకు దూరాన్ని కనుక్కోవాలి. So one is origin and another is 3 minus 2, 4. So distance between origin to any point, you write the formula. Distance between origin to given point is x coordinate square plus y coordinate square plus z coordinate square. This is the formula. Very, very simple. Under root, here x coordinate is 3, 3 square, y coordinate minus 2 square, z coordinate is 4, 4 square. 3 square is 9, minus 2 square is 4, 4 square is 16. So 16 plus 4, 20 plus 9, 29 under root. So the distance between this origin and the point is under root 24. Now let us take one more question. Find the distance between 2 points. Find the distance between 3, 4 minus 2 and 107. Two points. Let first point as B and second as B, first as A. So 107. So when 2 points are given, first point is x1, y1, z1. Second point x2, y2, z2. Then the formula distance between 2 points x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under root. Now, so this is the formula. x2 minus x1, 1 minus 3 or 3 minus 1, anyhow you are taking square, it doesn't make any difference. You can subtract A from B or B from A. Em teda undadu. So avoid confusion. I take x2 minus x1 as it is. 1 minus 3 whole square plus y2 minus y1, 0 minus 4 whole square, z2 minus z1, 7 minus 2, 7 minus 2, 7 plus 2, minus becomes plus. So under root. So you can write 1 minus 3 minus 2, 0 minus 4 minus 4, 7 plus 2, 9. Minus 2 square plus 4, minus 4 square plus 16, minus into minus plus, 9 into 9, 9 square, 81. 16 plus 4, 20 plus 80, 100 and 1. So here the distance between these 2 points, you practice more number of problems. Based on this distance formula, lot of questions you can solve. Now let us take up one more question from the exercise Roman 2, first problem. Find x if the distance of these two is 9. Find x value if the distance between the 2 points 5 minus 1, 7, and x 5, 1, x 5, 1, 1. In second point, x coordinate is not given, it is given as x. And the distance is 9 units. Already the distance is given, we have to find the x value. Same. Take let 2 points, first point a 5 minus 1 7 and b second point x 5 1. Let the first point be x1 y1 z1, second point x2 y2 z2. And take the formula. Take the formula. Here formula is x2 minus x1 whole square plus y2 minus y1 whole square z2 minus z1 whole square under root. Using this formula and the given condition, the distance, here the distance is already given. The distance AB is 9 units. So this is given condition. Squaring both sides, otherwise you can write as it is. Now AB x2 minus x1. Here x minus 5 whole square. y2 minus y1, 5 minus minus 1, 5 minus minus plus 1. z2 minus z1, 1 minus 7 under root is equal to 9. Now squaring both sides, the root will go away. Squaring both sides. Squaring on both sides. You can remove the root. X square minus 2ab, 2 into 5, 10x, plus b square, 5 square is 25. 5 plus 1, 6, 6 square is 36. 1 minus 7 is minus 6 square is 36. And 9 square is 81. 81. Now bring 81 left side, further simplifying. x square minus 10x. This is 36 plus 25. 97. And 81 becomes minus 81. Further, subtracting 81 from 97, x square minus 10x plus 16. This is a quadratic equation, Varga Samikaranam. Factorizing this, you will get x value solving. So 10 minus 10 can be written as 8 plus 2 or minus 8x minus 2x. Though splitting minus 10x as minus 8x minus 2x and remaining right as it is, x square. This you know how to take factors for a quadratic equation. Splitting the middle term and taking common from first two terms, take x common from first two terms, x square. If you take x from minus 8x, you will remain 8. And from 2x 16, if you take 2 common, x minus 8. Again, x minus 8 taking common, x minus 2 will remain. So these are the factors. This is factorization method for solving any quadratic equation. Now, equating both factors to 0, x minus 2, 0, x minus 8 becomes plus 8, x minus 2 becomes plus 2. Therefore, the x values are 8 and 2. Now let us take another question. Second question. Show that two, 3, 5 minus 1, 5 minus 1. 4 minus 3, 2. Form a right angled isosceles triangle. Form a right angle isosceles triangle. ఈ మూడు బిందువులు లంబకోణ సమద్విబాహు త్రిభుజం ఏర్పరుస్తాయని చూపాలి. లంబకోణ సమద్విబాహు త్రిభుజము right angled isosceles triangle. You know what is right angled isosceles triangle? One angle is 90 degrees. So Pythagoras theorem you can prove, and two sides are equal. So it is a triangle where two sides are equal. It is a right angle triangle, two sides are equal. Here angle is 90 degrees. We have to prove. So let first point as A, second point B, and third point as C. We are naming the points. Now let us find the distance between distance of all the sides. So AB, x2 minus x1 whole square, y2 minus y1 and z2 minus z1. Whenever you want to find the distance, use this formula only. So this is the distance formula. By using this formula, we calculate three distances. We want length of three sides. So AB, BC, CA. So now let us take first 2 points. x2 minus x1, minus 1 minus 2. Minus 1 minus 2 whole square. y2 minus y1, 5 minus 3 whole square. z2 minus z1, minus 1 minus 5 whole square under root. Minus 1 minus 2, minus 3, 5 minus 3, 2, minus 1 minus 5, minus 6. So this is 3 square 9, 2 square 4, 6 square 36. This is 49. 49. Now AB is equal to root 49. If you take the square, AB square is 49. So this is the first side. Similarly, you can find BC, AB, BC. Now you take B, minus 1, 5 minus 1. And C, 4 minus 3, 2. Now let us find distance between BC. 4 minus minus 1, 4 plus 1. Minus 3 minus 5 whole square. 2 minus minus 1, 2 plus 1. Similarly, subtract x coordinates, y coordinates and z coordinates. X లో నుంచి x తీసేయాలి, y లో నుంచి y, z లో నుంచి z. రెండు బిందువుల నుంచి. 4 plus 1, 5. Minus 3 minus 5, minus 8. 2 plus 1, 3. 5 square is 25. 8 square is 64. Plus 3 square is 9. So this is 64 plus 24. 89 plus 9, 98. So this is equal to BC is equal to under root 98, or BC square is equal to 98. So this is second side, రెండవ భుజం. ఇప్పుడు మూడవ భుజం కనుక్కుంటే, that is CA or AC. C 4 minus 3 2 A 2 3 5 CA 2 minus 4 x2 minus x1 whole square 3 minus minus 3 so 3 plus 3 5 minus 2 z2 minus z1 whole square is 5 minus 2 this is under root is equal to 2 minus 4 is minus 2 3 plus 3 is 6 5 minus 2 3 minus 2 square 4 6 square 36 3 square 9 36 4 40 plus 9 this is 49 therefore the third side CA is root 49 if you take the square squaring on both sides CA square is 49 root will go this is third side. Now we have to prove that this is a right angled triangle. For right angled triangle, we use Pythagoras theorem. Now, by Pythagoras theorem, we prove sum of the squares of any two sides is equal to the square of the third side, then it is a right angle triangle. రెండు భుజాల వర్గాల మొత్తం మూడవ భుజం యొక్క వర్గానికి సమానమైతే అది లంబకోణ త్రిభుజం. సో హియర్ BC square is equal to AB square plus CA square. So here what we observe, first AB square plus AC square or CA square is equal to BC square. AB square is 49, CA square is also 49, 49 plus 49 is 98. Therefore, by Pythagoras, and these two sides are equal, AB is equal to AC or CA. Therefore, it is a right angle triangle and isosceles. So it is a right angled isosceles triangle. Triangle ABC is a right angled isosceles. Right angled isosceles triangle. లంబకోణ సమద్విబాహు త్రిభుజం. సో లంబకోణ సమద్విబాహు లంబకోణం అంటే పైథాగరస్. సో దిస్ ఇస్ we are using by Pythagoras theorem. Pythagoras కర్ణం మీద వర్గం మిగతా రెండు భుజాల వర్గాల మొత్తానికి సమానం. So here BC is the longest side. So in this it is the hypotenuse. ఈ త్రిభుజానికి BC ఇక్కడ BC is కర్ణం. So the other vertex is A. You can observe where is the 90 degrees angle. The right angle is at A. So it is opposite to the hypotenuse. కర్ణానికి ఎదురుగా ఉండేది 90 డిగ్రీలు ఉంటుంది. మూడిట్లలో పొడవైంది కర్ణం. సో మిగతావి ఆసన్న భుజాలు ఏబిఏసి, బీసీ అనేది కర్ణం. You can observe this also. If this question is asked, at which vertex the angle is 90 degrees? ఏ శీర్షం వద్ద కోణం 90 డిగ్రీలు ఉంది? ఇది హైపోటెనస్, కర్ణం, ఇవి రెండు భుజాలు. సో ఇది పైథాగరస్ థీరాన్ని పాటిస్తుంది కాబట్టి లంబకోణ త్రిభుజం. అదేవిధంగా రెండు భుజాలు సమానంగా ఉన్నాయి కాబట్టి ఇది సమద్విబాహు త్రిభుజము. సో దీన్ని లంబకోణ సమద్విబాహు త్రిభుజం అంటారు. రైట్ యాంగిల్డ్ ఐసోసెలస్ ట్రయాంగిల్. Now let us take one more question. Show that one, two, three, 701 minus 2, 3, 4. These 3 points are collinear. సరేకియాలు కొలీనియర్ పాయింట్స్ అని చూపించాలి. అంటే ఒకే రేఖ పైన ఉండే బిందువులు. పాయింట్స్ ఆన్ ద సేమ్ లైన్ ఆర్ కాల్డ్ కొలీనియర్ పాయింట్స్. Let us name them as A, first point, B, second point, C, third point, or you can take PQ or also or XYZ. Now we have to show that these 3 points are on the same line, collinear. There are so many methods you can prove that they are collinear, but here we make use of the distance formula. By finding the distance, sum of the two distance is equal to the distance of third side, just like in the previous problem for right angle triangle. Here also we make use of the distance. So find all the 3 distances AB, BC, CA. Then if sum of any 2 is equal to the third distance, then the points are collinear. In above previous problem, Pythagoras is different. Squares, sum of the squares of the any 2 sides is equal to the square of the third side, then it is a right angle triangle. Here we are taking only distances for collinear. Now let us find AB distance under root x2 minus x1, 7 minus 1 whole square, y2 minus y1, 0 minus 2 whole square, 1 minus 3 whole square, z2 minus z1, 7 minus 1, 6 square, minus 2 square, 1 minus 3 is minus 2. 6 square is 36, 2 square 4. This is 44. 36 plus 4, 40 plus 4, 44. Now AB is 44 can be written as 11 into 4 or 4 into 11. So for root 4 is 2. So this is equal to 2 root 11. So AB first distance 2 root 11. Now let us find BC. Take B point 701 and C minus 234. BC using the same formula, x2 minus x1 minus 2 minus 7 whole square, y2 minus y1 3 minus 0 whole square, 4 minus 1 z2 minus z1 4 minus 1 whole square. Further subtracting 2 minus 7 minus 9, 3 square, 4 minus 1, 3 square. 9 square 81, 3 square 9, 3 square 9. 81 plus 9, 90 plus 9, 99 root. Now BC is equal to, this can be written as 11 into 9 or 9 into 11. So root 9 is 3. So this is equal to 3 root 11 BC. Now let us find the third distance between C and A, or A and C. Minus 2, 3, 4. First point 1, 2, 3. CA under root x2 minus x1, 1 minus minus 2, 1 plus 2. y2 minus y1, 2 minus 3 whole square. z2 minus z1, 3 minus 4 whole square. 1 plus 2, 3 square. 2 minus 3, minus 1 square. 3 minus 4, minus 1 square. 3 square is 9, 1 square is 1. So this is 9 plus 1 plus 1 is 11. So CA is root 11. This is third. So to prove the 3 points are collinear, already I told you in the beginning, sum of 2 should be equal to the third distance. So 2 root 2, 3 root 2, root 2. So 2 root 2 plus root 2 will be 3 root 2. So here what do you observe? We observe AB plus CA is equal to 2 root 11 plus root 11, that is equal to 3 root 11. So this is AB plus CA is equal to 3 root 11 is BC. So BC, A is in between BC. The points are like this. B, C. So A is there. So AB plus AC, we are getting BC distance. So AB is 2 root 2, 2 root 11, AC is root 11, and the BC is 3 root 11. Therefore, these 3 points B, AC or ACB or ABC, the 3 points are collinear. Therefore, the given points the given points are collinear సరేఖియాలు ఒకే రేఖ పైన ఉన్న బిందువులు. Okay, this is very easy chapter. You will get one short answer type, very short answer type question from this. So we will continue in the next class. We will continue to solve some more problems from this chapter in the next class. Keep watching.